Good morning, everyone. Welcome to today's meeting, the AWHI Advanced Water Heating Initiating Equity Working Group meeting for the month of March. Today, it's going to be a 1 hour spotlight presentation meeting, and we have two manufacturers who are going to talk about their split system product that is not unique in a way, but a different heat pump water heater technology that could actually cater to the multifamily building units. And we are most interested to know how it could actually make a difference to affordable housing providers. So that's the theme for today. And before we move on to that, I just want to give a quick highlights and updates. If you are new and if this is your first time attending this meeting, please do come forward and introduce yourself to the group. It's really nice to say hi and have some greetings here. So I know for sure there are like at least 2 or 3 people who are attending this meeting for the first time. So not going to pick out anyone. Feel free to raise your hand and come and say hi to us.
I'm Bruce from Smart Solar. Thank you for having me.
Hey Bruce, thank you for joining us.
Hi everyone, I'm Charlie Simic from New Ecology. We're a nonprofit in Boston that does electrification and energy efficiency and affordable multifamily housing, and I'm an engineer there.
Hi Charles, nice meeting you. I think you were also there at the Hot Water Forum.
Yes, we presented on our central heat pump hot water heater pilot projects.
Yeah, absolutely. I saw the presentation link. Thank you so much for joining us today. Who wants to go next? Doug?
Sure. Hi, all. My name is Doug Quattrochi. I'm the Executive Director of Mass Landlords, which is a Massachusetts-based nonprofit trade association for rental housing providers. We have about 2,500 dues-paying members who operate about 60,000, 70,000 rental units in Massachusetts.
Thank you for joining us today. Welcome to the group. Nick, would you like to go next?
Sure. My name is Nick Kestner. I'm the Building Decarbonization Coordinator for the City of San Francisco. Glad to be here.
Thank you, Nick, for joining us. Sarah, you're up for next.
Hi, my name is Sarah Chimberg. I'm a regulatory engineer with MyDia. If you're not familiar with us, we're a large home appliance, or we're one of the largest home appliance manufacturers in the world.
That's wonderful. Thank you for joining us, Sarah. Tom.
Hello, I'm Tom Cabot, an energy engineer in Menlo Park, California, helping various nonprofits.
Wonderful. Thank you for joining us, Tom. And let's move forward. I hope I have not missed out anybody else. Anyone else new to the group? Or do you have any updates to share? Is there anything that you'd like to talk about? Any projects or anything new that you have come across regarding policies or some administration changes or any new funds and grants? Is there any update that you'd like to share? Anyone? Okay, looks cool. Okay, now we'll move on to the next session. Just a quick update on the ACWA Hot Water Forum. Deepthi, myself, Bill Leons, who's also a member of this group, we all were there at the Hot Water Forum in different sessions for affordable multifamily housing, decarbonization, and moving utility efficiency programs. So I just like put some of the links, the sessions that I was also a part of. Also, you can find the link here for all the programs and presentations. So feel free to sort of go through the links, go through the presentations. You'll find something useful as well because all these presentations were pretty insightful. The one of the presentations that the session that I was in, it was also on like trying to balance the economics of domestic hot water in New York City. So it's not just about like having 100% heat pump water heater trying to pull out the load annually. It was more about like, because it's expensive compared to the gas price, the electricity price was quite high. So they were trying to balance it in a way like 70% of the domestic hot water load annually through the heat pump, and 30% probably could be used during a switch rate using gas. So that was a different approach I felt for domestic hot water, where you can definitely not offset the cost when it comes to a more economical gas price. So that was one of the interesting presentations that I really liked. You can also look into the hot water innovation prize that is trying to sort of encourage manufacturers to come up with a different kind of design with split system that can sort of overcome the space constraint, the noise constraint in multifamily buildings. So where it can exactly be located, like in a breezeway or an outdoor closet, or even if it's inside, how can it minimize, like not taking up too much of the living space and also reduce the noise? Bill also presented on electrifying Evanston. The link is not there for the presentation, but Bill has definitely acknowledged that he will give us a presentation sometime later, I think in the month of May, when we'll have another spotlight presentation. So that will be all. Dipti, would you like to give a highlight about your presentation?
Sure, thanks, Vidisha. Yeah, so my presentation was more about not just about heat pump water heaters, but in general and as a holistic transformation for market. How can we use the technical reference manuals that multiple states in the Northeast use uh, to align or to streamline their goals with like state energy offices, utilities, and implementers? How can we better use them to align with the decarb goals that we have? And NEEP region has pretty aggressive decarb goals. So we were looking into different options or different scenarios, like how this can be better presented in a technical reference manual so it can be better understood across the board. And we'll probably be working with some utilities, some state energy offices, and maybe some national labs to put something together. And it's just the beginning of the research now, and we just proposed this, and a lot of interest was shown at the conference. So it's a good project to take on.
Thank you so much, Dipti, for that quick overview. So yes, we did have a lot of insightful presentations. So feel free to hop on the link and get some presentations in your free time. Let's move forward to the presentation that we have today for this meeting. I'd like to invite Carl for the first presentation. This is about a split system. I've always been very much interested in trying to understand this technology, given the fact that personally I feel it sort of really understands the space issues and like it can divide these components into two parts. One is inside, one component is outside. Your noise is almost reduced. But what I'm most interested right now is trying to understand the economics of this technology. Like, are we going to bring down the cost, and how this actually can be like a benchmark for affordable housing providers, that they can actually say that this product is affordable. So Carl, over to you. I can move the slides, but if you would like to take control and move the slides yourself, it's totally fine.
I think I already did. I hope you see my screen. Does anybody see my screen?
I can see your screen. It's totally fine.
Great. Okay. Hi, I'm Carl. I'm with Ecological. We have a very interesting approach to the market because we're not traditionally a water heater company. We actually started out years ago, decades ago, in the energy efficiency business, where we supplied energy efficiency products to homes of all levels, low income, moderate income, and through retail programs, things from advanced power strips to LED light bulbs to spray foam, everything you can imagine. So the company Ecological is really built out of trying to create a product for electrification and decarbonization that's really geared towards the utility industry. And that's really where our heads are. And we offer two types of water heaters. We have an integrated tower, which is on the right, and that's actually made by Medea, who's on the line. I'm proud to say, high quality product, very nice. And then we have the split system, which I'll probably spend all my time talking about, and I'll try to be brief because after this, please feel free to reach out with any questions. So just the basics on how our system works. It basically, you put the heat pump outside, it sucks in ambient air and takes out the heat energy, and it uses that heat energy to help superheat the Freon, that runs through the heat pump, and that runs into the tank that's located inside, and then it sends the liquid refrigerant back out to the heat pump to do the process over and over. So it's really just a cycle that just constantly goes, just like a regular heat pump that you see in a home, an integrated tower. But the big difference is we put the system outside, so all the noise and the drainage and the condensate, all the negatives of an integrated tower just get moved outside. And for our split system, we have three product lines. And we have what we call the Omni 80-gallon 240 volt, the Omni 50-gallon 240 volt, and the Omni 50-gallon 120 volt. And with these units, they'll all be fully certified. They'll be Energy Star 5.0, Energy Star Advanced Communication, NEA 8.1, and they will range actually from NEA Tier 3 to Tier 4. We just have some new updates coming, so we're able to update this little 2 here. UL listed, EcoPort certified, so it's demand response ready. And for California, it'll be JA13 compliant, which that just means that it has time of use functionality, so a customer can set time of use rates if they have them in their area. And the rest of these are California requirements. So we'll be very certified, probably more so than most states will require. But the cool thing is we're demand response ready because we think that's where this technology it needs to go. And one of the bigger things that we did on the cutting edge side is we already moved to R513A for a refrigerant. It's a much lower global warming potential score than R134A, which is currently used in most heat pump water heaters. So we really think we're kind of setting the stage and just being a little more proactive before it's a requirement. And there's that R5113A again. We're very proud of that. But just to give you an idea, this is across the range of products. Our UEF, again, with recent testing, that has gone up. Our UEF ranges from 3.5 to 4.4, and 4.4 is going to be one of the highest in the industry for a heat pump water heater. Our COP is 4.5. We use a DC inverted heat pump. It's a dual rotary heat pump, so it helps us come under the required sound level. But what's great about it is if you can imagine compared to a standard heat pump water heater, they have what they call a static or they call it a static drive. So it's either on or off. So when it needs demand, it just turns on full blast. And when it doesn't need it, it completely turns off. So it's kind of like a car that just stops and goes. Where we're using a DC inverter heat pump, which allows it to throttle up and down. So we only use the amount of power we need to run the pump that's necessary to meet the demand. So that helps us become very efficient. The 120 volt version is really for climates from the Carolinas south. And the 240 volt is definitely our cold climate version. And we designed it specifically for the Northeast. And our operating temperature on heat pump only is down to 5 degrees Fahrenheit, up to 120 degrees Fahrenheit. And beyond that range, it'll disable the heat pump and it'll go into resistance mode. So effectively, we have a heat pump that's doing the work most of the time. But if you're outside these operating ranges, we have dual elements inside our tank. And I don't know how technical we want to get, but on the 120 volt version, it's a 1,000 watt element in the top and a 1,000 watt element in the bottom. And the 240 volt version, it's a 4,500 watt element in the top and a 4,500 watt element in the bottom. And just so people don't get too excited, they never come on at the same time. Only one at a time comes on. And we do feature microchannel heat exchanger and blue crystal ceramic lining, which is an antibacterial lining to kind of help just keep your water clean. And some of the installation benefits are, we're trying to make this as economical as we can, especially for our targeted market. And our targeted market is, it's the people who can't get this technology or can't be an early adopter on their own. They're worrying about their own bills and they're worrying about other things. So when a crisis comes and they need to replace their hot water heater, the last thing they're going to do is look at a $2,500 water heater. So we try to make this as cost effective as possible. And a lot of that has to do with installation. So part of the installation process is using a quick connect system. So our heat pump is fully charged. Our tank is fully charged, and the line set we provide, which is 16 feet, that is also fully charged. So an installer doesn't have to have an HVAC license to install our product. They just screw it in and it opens the seals. Some additional benefits would be the Omni runs refrigerant through the wall. Some other split systems will run water through the wall. And we thought if we're going to feature, hard to reach housing in the Northeast, we don't want to put something where you need heat tape to keep the pipes warm in cold weather. So it was really important for us to use refrigerant through the wall instead of water. We have a very slim tank, which means there's no need for venting, and it allows you to put our system in the tightest installation places. So it makes it really perfect for alternative dwelling units, multifamily, and mobile homes. With our 120 volt model, which we wouldn't use in the Northeast, and I think that's what most of us are focusing on. But if you were able to use a 120 volt model, it's good news because you don't have to upgrade the panel with a 240 service. In the motivation behind this product, the reason why we went down the split system path is because it's about real world experience. We started first with an integrated tower, which I showed you, but then we noticed something that was really interesting, and it was kind of odd. There just simply wasn't a solution that would overcome the barriers of an integrated tower. And we came from an Australian background. Our company has people that worked in Australia and did heat pump programs there. And we saw there that integrated towers had a lot of barriers, and the way that the tradesmen overcame it is they demanded a split system. So that's why we said, hey, let's do that here in the US. We saw the same issue. But to drive that point further home, we realized there was a serious lack of heat pump water heater technology for things like mobile homes and ADUs and multifamily. Because when you put a big giant heat pump water heater in somebody's house, you create a lot of barriers. So it was very important for us to try and help that hard to reach community that just doesn't have the one, the knowledge, or two, the means to go with this very expensive technology. So early retirement's important to us. Targeting underserved communities where they could stand for a good hot water heater upgrade and help them be part of the solution where they can't normally when this technology is so expensive. And we hope the prices will come down, but we're going to do everything we can to make it affordable for those types of programs in those communities. And I mentioned it just a second ago, early retirement is really key for us. We're very different. We're not like a Rheem or an A.O. Smith. We don't put our product at Lowe's and Home Depot or stick it on shelves and hope somebody picks us when there's a crisis. We like to work with utility programs to identify the opportunities in the communities that need the assistance, and we'll work directly with their installers and try and help get sections of housing outfitted rather than waiting for failures. Because we think that market transformation is key, but if you're going to wait for every water heater to fail and hope people pick the right one, it's going to be very tough to get market transformation. So we really want to help with early retirement programs and working directly with folks. And just some of the simple numbers. I mean, everybody kind of knows this. There's a huge reduction in electricity use. If you're going from electric to electric, you're reducing the energy use by about 75%, which is huge, especially in homes that are heating with electric or heating their water with electric. And then if you're going from gas, if you're fuel switching, going from gas to electric, we're still a large savings. We're a 50% reduction over gas, and that's quite a bit of money in somebody's pocket at the end of the year. Even, for electric, it's about $550. For gas, it's about $350. And before I do say thank you and close out, the one thing I wanted to mention, I don't know how many of you are heat pump water heater experts, but the one thing that's really important to know is that the UEF factor is really the COP is really an interesting thing. The COP is the coefficient of performance. When you look at an electric water heater or a gas water heater, it's below 1.0. So it's usually, I think gas might be 0.7, and I think electric might be even lower than that. And what a COP of 4.5 means, for every dollar of electricity you spend, you get $4.50 back in heat energy. So if you think about that, a 1-to-1, so if it's a COP of 1, for every dollar of hot water you spend, it costs you $1 of energy. With this, you can see that it's 4 times more efficient when you look at a COP of 4.5. I just thought that was something that was kind of important, and that's really why we're targeting underserved communities and hard to reach communities. So now I'll go back to the monkey. That was it. Brief, like I said.
Thank you, Carl, for that.
Sure.
Is anyone having any questions? Please feel free to ask Carl. Yes, Doug.
Hey, Carl, thanks very much for that presentation. Do you imagine maybe that there could be custom ordered line sets of different lengths? Is 16 feet a performance maximum, or could we go longer than that?
Well, I'm glad you asked. Like Bruce, we're really new to this industry and we're new to the market. We just launched this product in March. Yes, so right now we settled at 16 feet because we did probably over a dozen installs in the targeted communities we're talking about, and 16 was more than enough. So 16 feet was enough for most homes, but if you need to go longer, you can have an HVAC person come in and vacuum the system and charge it and add lines up to 30 feet. So it's capable of doing 30-foot runs. It's a standard 16-foot line set. As we sell more into the market and see the demand, we'll either offer alternative lengths or we'll just adjust to what the average is.
Okay, thanks very much.
Sure.
I have a question, Carl. I just want to understand the cost here. Like, what would be the cost for like overall with the unit and the installation?
Well, that's installation's all over the board. Unfortunately, installation becomes the victim of what's the incentive. The unit itself, the MSRP is $29.95. But when it comes to installation, it really depends how many hours the installer wants to charge and what they think they can get for an incentive. So in California, the incentive is very high. In Maine, it's even higher. I mean, an installer will get $2,600 to install one of these. But if the average customer were to call a plumber and say, hey, what's it cost to install this? It could be up to $2,000. And the variability could also increase because they need a panel upgrade. If they need a panel upgrade, it gets very expensive. It's an additional $2,000 with a panel upgrade.
And with the 120, would that also require a panel upgrade?
No, it does require a dedicated run because we put heat elements in it. It does require a dedicated 110 volt circuit, but not a panel upgrade, just basically a home run from the panel to the water heater.
Thank you for that information. Anybody else, any questions? Sorry, Tom had a question. What are the first hour ratings of the units?
Oh, yeah, that's a good question. The first hour rating of the 120 volt is 55, and I'm trying to remember these off the top of my head. And the 240 volt 50 gallon is 57, and the 80 gallon 240 volt is 85. So that was 55, 57, and 85.
Thank Carl. I also have one follow-up question. So the product has not been so far like any field demonstrations in US, right?
We did some field demonstrations with a slightly different unit. The unit didn't have backup heat elements, and we installed about 12 of those, and they're performing excellent. None in cold climates because that's just not what they were made for without a heat element. So we have units landing in May, and we have quite a few customers, utilities included, waiting for the sample units to get them installed. So we'll have info, just not yet.
So the initial field demonstration that you had without the backup heating element, did you have any other noise issues or any like space constraint? Where is located, like in the multifamily building?
No, we didn't. It's kind of a funny thing because if you look at the criteria from NEA requires for integrated towers that go in your house, they require a decibel rating of 55. But for the split systems, they require a decibel rating of 50. So we're below that 50. And so far, we haven't had any complaints about the noise because keep in mind, they're not like a ductless mini split that when you use them, they're constantly going. These only operate maybe 2 to maybe 3 hours, and it's on and off. It's never constant. So they don't run all the time. And when they do, they're under 49 decibels.
Okay. Thank you for that. Deepti, do you have any questions on this?
No, I'm good. Thank you. The great presentation, Carl.
Thanks.
Thank you so much, Carl, for the presentation. Probably we'll have more follow-up questions later. But now I'd like to move forward to the next presenter. Bruce, I'd like to invite you and let's talk about solar-assisted split heat pump water heater. And I can move the slides for you, Bruce, so don't worry.
All right. So a little bit about ourselves. If you haven't heard of Smart Solar, you haven't been professionally remiss or anything like that. We're brand new, like Carl. We just started our marketing efforts this year. Our website is brand new. The company was founded in 2023 with a prototype. We got through UL and Energy Star relatively quickly, and by the end of 2023, we had our first manufactured units. In 2024, we knew we were only going to get about 200 manufactured units, and we also knew that we'd sell them. So we knew how the system would perform. We had all kinds of data, and we've access to pretty good modeling as we developed the product. So we weren't concerned about field performance, but we were concerned about documentation and whatnot, and homeowners and stuff like that. So we wanted to get a bunch of them out in the field before we, before all this saw the light of day. On the right side of the slide, you can see the three components. It's a split system, of course. The difference is that our evaporator is a flat panel, so there's no fan coil unit, there's no fan. It replaces Carl's evaporator, which is a fan and a fan coil unit with a large panel that may or may not be in the sun. It doesn't have to be in the sun, and it replaces a fan coil with surface area, basically. So next, please. Sorry, we're looking at the same slide. This is the schematic.
Is the slide that you want, Bruce?
Yeah, it is. So in any event, three components. Again, the sun is shown illuminating on the panel, but the panel is designed to work by convection, right? Moving air. So if it's in the sun, that's fine. But as a test conditions have it, Energy Star, they don't have a special testing protocol for split systems, much less our split system. So they put it in the same test conditions as a regular unitary heat pump, which means that the UEF test conditions are no sun and no moving air, which is a disadvantage for us, but it opens the doors to rebates and stuff like that. Next slide. Sorry, my slides aren't moving. Am I doing it myself?
Did someone take control of the presentation here?
I am sorry. I think I did that by mistake.
Oh, that's completely all right with me. I'll just move the slides.
So,
Is this slide, Bruce? The multifamily
yeah,
project?
so is everybody still looking at the schematic, kind of the cartoon schematic?
No, we are at the multifamily project slide.
That's not what I'm looking at. That's not the slide I had intended to be at. So I was on the second. I'm done with the second slide, hoping to go to the third slide.
This one?
My screen's not even changing.
Cartoon slide now.
Are you able to see this?
The schematic slide.
All right, I'm looking at the schematic slide. I'm hoping to
Right.
get to the next one.
Right, now is it moving?
No,
Are you able to
mine is not. I don't know what everybody else
Now
is
we
seeing.
see the graph slide.
Oh boy. All right, I'm gonna move manually.
Sure, yeah, because we are able to see the slides, but I think there is an
All right.
issue at
So we're we're a core differentiator. The core differentiator for our product is is of course the outdoor heat panel. The two photos on the right are showing kind of real world installations as opposed to the beauty shots that you might have on the website. The one on the left shows the panel mounted sideways. The orientation doesn't matter. And not only that, it's it's behind the landscaping. It's in the shade. So I like that photo because it illustrates the fact that direct sunlight is not needed, and more often than not, these panels are not in direct sunlight. On the right is also pretty typical. That panel happens to be next to the heat pump equipment. You can see a little sliver of the the space heating evaporator, and of course a disconnect. That's often where we end up. And in fact, that panel, since it's intended to work by convection, likes to moving air from the evaporator, even if it's cold air during heating season. So, the advantage of a split system such as this or Carl's is that the evaporator is outside. but then to an extent, the disadvantage is that it's, it's outside. So if you look at the graph on the left, which, there's a link to specifications coming up quickly, so you don't have to peer at that graph, but, no surprise to anybody, the performance and the capacity of the system is a function of the conditions outdoors. So on the left side of that graph, temperatures on the bottom, we're showing the coefficient of performance at 0 degrees, and on the right side, of course, when it's 90 degrees, we're showing the coefficient of performance when it's when it's hot. The different lines represent sunlight. So the blue line on top shows the panel performance when it's in full sun, and then the red line in the bottom shows the system performance when there's no sun on the panel whatsoever. And of course, as I just mentioned, the Energy Star test condition is tested with no sun. Next slide. So I'm
this slide, Bruce, in case you're not able to see.
Yeah. So I'm at heating capacity and advantages, correct?
Correct.
Excellent.
Yes.
All right. So, I'll read through the advantages, but the advantages are of a split system in general, whether it's ours or someone else's, is that, of course, that the evaporator is outside. So inside, you have no blowing cold air. You're not consuming room air, obviously. There's no requirements for air volume from which to steal that air or ventilation, no room size requirements. In our case, we have no outdoor electrical. We have no ground mounted equipment. In some cases, we've had, there's been issues with pad mounted equipment and potential vandalism at some of our multifamilies. And obviously, we're not pumping portable water outside. These panels can go on a flat roof, and we've put them on a flat roof. You can put them on a flat roof, and you could ballast them with racking, similar to a solar electric system. Our heat pump is also 120 volt, although we're in New England, and that's where our initial base of installations will be. So the tank has an optional separate 240 volt resistance backup. It's 4,500 watts. Although we definitely have customers, residential customers, who have told us they don't want the backup element wired. They just want to know that they're in heat pump mode all the time. And similarly, we have people with energy monitoring. Lots of early adopters, and they can see the loads, and we have people report that, with the exception of installation day when the tank was cold, the backup electric element has never come on. The big advantage of this thing is that it's simple, right? There's a variety of designs. This is, I dare say, this is the simplest. Detractors might say unsophisticated, but I still like simple, right? So we have a single speed compressor and a single tank sensor, and it's not going to break. All right. Energy Star, as you're probably aware, makes you offer a 10-year warranty on these things. We're cognizant of that, and so these things are simple. And we have no defrost cycle, right? Our graph, and I think Energy Star has our minimum operating temperature at 0 or -10 or something like that. But that's just because we need a number. As a practical matter, this thing keeps working down to -20 or -30 Fahrenheit. The performance will suffer as it goes that low, but there's no fan coil to frost up. There's no defrost. That panel that in the previous pictures, that'll get ice on it, and that's fine with us. The big disadvantage, again, I don't think our product or any product in the heat pump water heater space is a panacea and a one size fits all. The disadvantage of a split system, and ours in particular, is that the performance is a function of the temperature and conditions outside. All right, so the operating coefficient of performance and the capacity will vary tremendously. Next one, please. This one says multifamily project. No?
Yes.
Perfect.
Yes.
All right. So this is in Worcester, Massachusetts, which is near our home base. And the reason I like this job is that it was we kind of responded to market conditions only. What I mean by that is that we've all been involved in lots of jobs where the owner has a mandate to adopt as many electrification or renewable facets as possible as they renovate, and maybe they've got special funding, and maybe in our case it would be the Mass Clean Energy Center. Maybe they're involved. In this case, it was just a new building owner who bought an extremely distressed 1970s all-electric building. It was occupied and was going to remain occupied, and he needed to get those nasty water heaters you see in the upper left. He needed to get them out of there and put something else in place. As it was, since this is HUD housing, there was no possibility of getting gas to the site, and even if he did, there was no possibility of venting it. So what we found when we got there, in 3 buildings, this is one building, 4 just conventional residential electric water heaters all jammed into a corner. They're 80-gallon water heaters, and as you probably know, you can't even buy those anymore. I think they were rented, and the rental company went out of business. And it was kind of a mess. Don't look at it too closely, but all those tanks are piped in series, which is not how you do it. So within a little over a week, we gave them 320-gallon smart solar systems. The first hour rating for those systems is about 136 gallons. That includes a contribution from the backup electric element. We didn't have to rewire anything. We used the existing 240-volt circuits that were running the original water heaters. And of course, the heat pump itself is a separate circuit, and that just plugs into the wall. Next slide.
The financials for multifamily Mill Street
Perfect.
units.
Perfect. So this is kind of, the financials for these projects, especially multifamilies, especially nonprofit, can be kind of complicated. So this is kind of a high level, high level view. So our system, we have these panels rated as a solar panel. So that means that we take advantage of a slightly different tax credit. This is a 30% solar investment tax credit. On residential, for example, it's called the 25D tax credit, as opposed to the 25C, which is a heat pump tax credit. The owner can also take advantage of accelerated depreciation and utility incentives. When he engaged our installer to build this thing, I'm not sure that he had looked deeply into all those things, although I'm sure he had a chance. He just needed those things out of there as he renovated the building, and we were the quickest and the best solution. System cost per building, again, 3 buildings, $18,000. You can see the effect of the tax credit and the net cost. And in each building, those 3 systems are going to save 16,000 kW a year. So the year one savings is $5,000, and the straight line payback is about 2 years. So you might say, if you can offer this solution, these savings for any electric building, why would we do anything else? What's the bad news? The bad news is that there was no space for storage tanks. So basically, the 3 tanks in the previous picture is all there was room for. So that means that even though this equipment is saving 16,000 kW a year, there is a very large reliance on the backup electric element. The total heating load for hot water per year is probably like 50,000 kW a year, and we're offsetting 16,000 kW a year. So, again, the unit economics are quite good, but the fraction of hot water that's being provided by heat pumps is relatively low due to the space constraints of the area. Next slide, if you don't mind, Melpit Village.
Yes, Melpit Village is on your screen.
Good. So in a lot of respects, this job is the antithesis of the previous one, meaning that it's not a distressed building, and POA, who's a large national nonprofit housing developer, preservation of affordable housing, POA. We've done a lot of jobs with them. This is the very progressive organization. And in this case, they chose to replace in each building either 3 or 4 regular resistance water heaters that were failing and replace them with our units. When they built the building, when they built this complex, they had looked at conventional unitary heat pumps, but those rooms are small and you can't, there's no air volume and stuff like that. So this is kind of our flagship project. It's brand new. We finished a month or so ago. We just started, and we're collecting all kinds of data. We have 12 120-gallon smart solar units. One of the buildings that we didn't touch also has unitary heat pump water heaters, and we put monitoring on those as well. And we fully expect to show that smart solar outperforms the unitary heat pump water heaters. And this was an important point. This was funded by the Mass Clean Energy Center. That's our, that's the Commonwealth of Massachusetts kind of, aggregator for, for all the renewable programs. A phenomenal organization. We've done a fair amount of stuff with them. Data collections in progress, and in a year or so we're gonna present data. That's it. I know I speak quickly, and that probably took a little longer than it should.
Bruce, you are completely fine. So we really enjoyed your presentation. I appreciate it. Thank you so much.
Thank you.
And I welcome questions from everyone in the group. I have one question, and it's for both of you actually, and especially to Carl. Carl, since you mentioned that you do not have these units displayed in any like distributors or wholesale retailers, if there is an issue for replacement, how does that work?
Oh, like I said, we're new to the industry. So what we're doing is we're doing alternative distribution. So we will find where there's programs that are running and they want to use our product, and we'll work with a large installer. I'll give an example. In New York, there's a large group called Helco, energy, and they want to install these for themselves, but they're also going to buy enough so they could supply all the plumbers in the area. And in some cases, we'll work with distributors that are already in this energy efficiency industry, like AM Conservation or American Electric, or people who don't traditionally sell plumbing supplies. We're giving them the opportunity to get into that world where they weren't before. And currently now, maybe your next question is about service. Currently now, similar to the integrated tower market, if there's a replacement needed, we swap the entire component. So if something's wrong with the heat pump, we supply a new heat pump. And whoever was installing those have established a training and a partnership with us, and they will have the units on hand for replacement and warranty issues. And like Bruce, we're holding to a 10-year warranty as required by the specifications for Energy Star and NEA. I hope that answered the question.
Oh, it certainly did, Carl. Thank you so much. Bruce, I had the same question for you as well. Since right now, like as you mentioned, that it's just started a year back and you have a specific region that you are catering to right now. But if you are expanding, how does this whole thing work with like stocking up the product and have like any sort of replacement issue if it comes up?
Yeah, our model is to engage specialized installers. We're not gonna like Carl. We're not gonna sell these things through distribution, right? So you're gonna have specialized installers that will stock, and obviously if something breaks, like our heat pump, it's modular. It's modular, it has handles on the side. You're replacing one component, as opposed to the whole thing as with a unitary heat pump water heater.
Okay, thank you. I do have questions in the chat as well as Doug. You can go first, and I can take Tom's question later.
Okay, thanks. Bruce, I think you mentioned in passing you had some vandalism. What are the outdoor panels made out of? Are they metal or they're glass like a solar panel?
No, they're made out of aluminum. If you saw one, there's not much to them. They weigh about 10 pounds. In the case of the vandalism concern in Worcester, it's just a matter of putting them high on the wall.
Okay, but if a kid hits a baseball into it, it's going to be okay.
It'll probably leave a dent, but it's not gonna leak. It's a roll bonded aluminum panel, so it's not like for example, a solar thermal panel, where it's got glass. Nothing like that.
Yeah, different from that. Okay, thank you.
Yeah.
Thank you, Doug. I'll just take Tom's question. Does Ecological split water heater need only one circuit that feeds both the outdoor compressor and the tank resistors? Carl, that's for you.
Yeah, whether it's the 120 volt version or the 240 volt version, it'll run from the home's panel to the tank, and then from the tank directly to the heat pump outside.
Thank you. Anybody else, any questions? Deepti, do you have any comments for this?
Yeah, actually, I did have a question. Actually, I was going to piggyback on your question about product availability, but also, Bruce, you mentioned that it's going to be installer specific. So are you planning to have like installer training workshops, and can a plumber, will it come to a stage where a plumber can also do this? I mean, like, how do you see it scaling?
No, so yes, on the training workshops, of course, for installers, we're targeting not plumbers, but rather mini split installers, heat pump installers, right? Because we're more concerned because we have a refrigeration component. Our line set can be 50 feet. It can be nothing. It can be 50 feet. So you're evacuating. So we're starting with mini split installers. It's one in particular we're working with where they hired a plumber specifically to install this project. The mini split installers, they go into a home, they take out the boiler or the gas furnace or whatever it is, and the homeowner invariably is left with whatever was there when the mini split installer showed up, gas, water heater or whatever, and they're forever asking the mini split installers, what do we do with this thing? And they don't really have a good answer besides resistance water heaters. And furthermore, once a mini split installer takes out the gas boiler or the furnace, the basement is cold. So you can't, in our climate, you can't have a heat pump water heater down there blowing cold air and potentially taking what's otherwise a 50-degree basement and turning it into a 40-degree basement.
One of the funny things, just to add on to that, when we were doing the market research 2 years ago, I was in New York City because that's a big target for us as well, and we visited a garden style type apartment building. I think it was 6 units, and in the basement they put, I don't need to mention the name, but they put 6 unitary towers in the basement, and it made it so cold they had to run space heaters to make them work. It was the funniest thing I'd ever seen. So that was kind of part of our validation for split systems being the right direction.
Yeah, I think I have come across that case study. I've actually seen pictures of that.
I have one follow-up question regarding the space constraint that Bruce, you had with one of your project. So in that case, are you targeting new construction, multifamily buildings? Because in retrofit, you would definitely have that challenge. And in new multifamily, like new construction, you have a little bit of control over the design and space. So is that like a target audience for your products?
I think at this stage of maturity, we're more reactive. We've sold a couple hundred of these things. I probably slightly less than half have been in multifamilies, including the projects you're looking at. We've also done a couple housing authorities, Nantucket Housing Authority, Jamestown Housing Authority. I think we're about to do Webster Housing Authority. These are all towns in Massachusetts. And they've all been retrofits, right? I guess on the residential side, we've had a handful of new construction, but where we've run the line set through finished spaces or something like that. But the answer to your question is these are mostly retrofits so far.
Okay. No, I just wanted to know, like, since you had an issue with like the space in one of the projects. So like, is there something that you're considering even for future projects to have more of like inclining towards new construction rather than retrofits so that you can have like better control over the space and design?
No, that might be the only time we've really had a major issue with space, quite honestly, right? So I think we're more flexible than unitary heat pump water heaters, and we should be able to, as long as there's space for something, we should be able to make it work.
Right. And also, Bruce, I also have the same question for you. Would you like to sort of break down the cost economics for the product here? I know we had the chat before, but just for
Yeah.
for the
Yeah. So the installed cost, again, this is residential, right? So on a residential basis, the installed cost is $6,500, but that includes the electrician running new circuitry, right? A 240-volt circuit for the backup electric element, and an outlet for the heat pump itself. When that's a particular configuration. If there's no wiring component, the installed cost is less. In Massachusetts, there's a generous rebate. So our retail MSRP is like $3,500. In Massachusetts, for example, they give a different rebate for a split system that happens to be $1,500, which is generous. So that gets us down to slightly less than $2,000 for the installer cost. And then, as Carl mentioned, the installer, they charge what they charge, but $6,500 with an electrician is the most common. And again, with the generous rebate in our home market of Massachusetts, the out of pocket will end up being about $3,600, including the electrician, which is comparable or slightly less to what the plumbers are getting for installing unitary heat pump water heaters here.
Thank you for that clarification, Bruce. One final chance. Anybody, any questions? I guess the presentation was very insightful. So we have like a lot of clarifications on the product. So thank you, Carl and Bruce, for your presentations. I really appreciate your time and also for all the insights that you have provided on the product. Definitely, we'd like to know more about these projects as we move forward, and I hope you'll keep us posted on what the results show up in all of these multifamily units where these units have been deployed. Deepti, any closing notes?
Yeah, thank you so much, Bruce and Carl, for your presentations. And yeah, really looking forward to seeing where these products are going to go and the kind of transformation that they are capable of. Thank you so much and good luck.
Thank you for having us.
Thank you so much.
Thank you.
And I'd also like to sort of follow up with you about like how are you reaching out to like different utility programs and trying to sort of enter into these affordable housing providers projects. So definitely, I think that's something for future discussion. But for now, yes, thank you so much. Before we close out, just like to let you all know that the next meeting would be on 30th April, the last Wednesday of the month. It will be a short power meeting for just 30 minutes. It's going to be like a quick update, and if there's any updates that you would like to share, or if there's any project that you would like to talk about, and just a meet and greet. So see you in the next meeting. Post that in May, we will have a spotlight presentation again. If you have any like topics that you really look forward to, or is something, if you know of someone who you think could be of a valuable person to present, you can always reach out to me and Dipti and let us know. We would be more than happy to include them in the group and have the presenter come forward and have the presentation. For now, we do have a one presenter sort of like confirmed. Bill would be talking about one of the projects that he's been working on in Illinois. But apart from that, we do have a second presenter slot available. So in case, if you have something in mind, do let us know. We look forward to your feedback because it really helps us get presentations that makes more sense to you and that are valuable to the group. But yes, on that note, I'd like to wrap up this meeting today. So thank you everyone for joining us. Have a great rest of your day.
Thank
Thank
you.
you all. Thank you.
Thank you.
Bye.
Thank you.